First of all, thank you for joining. I wasn't sure if we were going to have 0 people here, but at least most people are friendly, except for my Dell friend here. But he's, it's all good. So my name's Eric Sindelar. My title is GM of Operations and Advanced Technology at Supermicro. I've been at the company for a little over 5 years. Before that, I spent 20 plus years at Intel. During that time, I also left for a year and was at a startup called VA Linux Systems in the 2000 timeframe. So for those of you who remember the spectacular rise and fall of VA Linux Systems, I was there for it. But I've been around Linux for a long time. And when I did leave Intel to go to VA Linux Systems, my feeling was I wasn't sure if VA Linux Systems was going to make it, but I knew Linux was. And so I knew it was going to be a great experience. So for me to be at a show like this and see Microsoft actually being one of the main presenters, it definitely warms my heart. So what I have today is a quick overview of Supermicro. I'm going to talk a little bit about the latest generation of Intel processors that launched on Tuesday and do a very high-level overview on some of our products that are associated with that launch. But I promise you it won't take an hour. And then what I'm going to do is kind of open up for very specific questions. I have a couple of my top Linux engineers in the room, so I'll introduce Alan Johnson. Wave to everybody, Alan, and Chengmu. So both Alan and Chengmu work on some of the key software solutions that we put together. So want to make sure that people can ask very specific technical questions once my presentation is done. So with that said, I'm going to have to do this old school because for some reason the plug and play does not work on my laptop. So first of all, I wanted to give you a little bit of background on Supermicro. Supermicro was started in 1993 by Charles Liang, his wife Sarah, and their friend Wally Lau. Wally and Charles and Sarah it was a true garage startup. So 3 people. Charles did all the engineering, and we've grown the company from very humble beginnings to being over about $3.5 billion right now from a revenue perspective. Back in 1993, Charles, he basically saw the vision of Intel-based servers. So he formed the company solely to do Intel-based servers. Now that, once again, that's obvious now, but back in 93, it was anything but obvious. I had just joined Intel. Intel had just released their first server chip, Pentium Pro, and Intel had no market share when it came to servers. So he was very visionary at that time. Now, the first board that he did was actually a dual processing Pentium motherboard. The local sales team, and I actually knew this person, basically stole some samples that were destined for HP and gave them to Charles and said, here you go. We really can't support you. You're just this one person, but here's some samples. Let's see what you can do with that. Well, Charles took his design, took the reference design, implemented it. It took him a couple of months, and he came back to Intel and said, here's your board. It works perfectly, and here's 3 bugs in your chipset. And so he was the first one to actually get a dual processing motherboard to work. So that's kind of where our humble beginnings is started. And we were fundamentally an engineering company. Our CEO, Charles Liang, still does 80% of the architecture. So all of our different system architectures are really driven by him. And that's what kind of sets Supermicro apart from our competitors. We fundamentally believe engineering matters, hardware matters, and we're going to always provide the best solution for you. So we started out as a motherboard company. You need to put motherboards in a chassis. You need to have it optimized. Sometimes it works, sometimes it doesn't work. And so very quickly he said, I need to get in the chassis and systems business. So he called up his brother in Taiwan and said, hey, get out of the testing business. I need you to get into the chassis business. So I refer to our brother company, Abelcom. I call them our brother company because it's owned by Charles' brother. So we design everything. Our brother company manufactures our power supplies and chassis. Those come over on a boat. We do all the design of our motherboards. Those are manufactured over in Taiwan. Those come over on a plane. But we do all final system assembly in the U.S. We have large factories in San Jose, probably over 500,000 square feet now, and we do all of our final system assembly in the U.S. So obviously CPUs come from Intel and AMD, memory comes in from Micron, Samsung, and Hynix, and then obviously the drive manufacturers, but all system assembly is done in the U.S. Now, at a time where a lot of companies are outsourcing their manufacturing, we're actually building plants in the U.S. And a lot of people are like, well, why can you how do you build computers or servers in the U.S. Cost effectively? And I go, well, it's just like building Tesla cars 10 miles up the road, because they're literally up the road from us. It's high ASP, it's custom, and people want it right away, and you can't just ship it on a boat. Not to mention all the quality issues that would come about with that. So if and what I like to say is we're building cars, because if you think of a fully loaded server, especially if you're doing anything with all flash, it's somewhere between $20,000 and $100,000. So, Jay is one of our customers. His systems come right out of our factory, and I think one of the benefits for Jay and a lot of the companies in the Valley is they can drive over if there's any issues. They don't have to get on a plane, fly for 24 hours, and go over to Asia. They pop in their car and they're over in 15 minutes. So, like I said, Supermicro evolved from being a motherboard company then into a systems company. But once you have systems, now you obviously need solutions. And so we partner with all the major software vendors to come up with those solutions. We provide reference designs. We provide complete solutions. We're very flexible in our business model. And so for us, that is what has made us unique. But one of the key things about Supermicro is that we're always going to optimize for your given solution. Charles modeled, was I'm going to do building blocks. So think of everything that we do is from a Lego perspective. You can build a lot of different things if you have core building blocks. So even our motherboards, we have hundreds of SKUs. But if you think about it logically, it's still building blocks, and we can move different subsystems and add subsystems such that you can get exactly what you need. Just like one car doesn't suit all of us, one server doesn't suit all of us. And we want to make sure that the vehicle for you is the most optimized. So there's many different vectors that we can optimize our servers on, and that's why we have such a broad portfolio. To some people it's confusing, but to us we fundamentally believe the hardware matters, and we want to make sure that you have the best solution for your given application across all vectors. On Tuesday, Intel launched their second generation of Intel Xeon Scalable processors, formerly known as Cascade Lake. We launched over 100 servers that support Cascade Lake. I think my Dell friends probably did 3 or 4, but that's our game is to make sure that not just 1 or 2 servers work, so that you can use our broad portfolio with the latest and greatest technology. So this is very important. If you look at the way Intel priced things, basically whether you went from generation 1 to generation 2, price is effectively the same. What they'll do is they'll give you more cores or more frequency, so you're going to get much better performance, performance per dollar. So if anybody's looking at buying a new server anytime soon, you should definitely use the second generation. Make sure you use Cascade Lake. From a memory perspective, if you're using the gold type SKUs, the bus has gone from 2666 up to 2933, and memory is already at parity. So you can get the exact same solution that you might have been buying with the first generation with the second generation for the same price. So you'll get all that performance advantages, for free. Question, Jay?
Does this work with the existing motherboards, or do you have to get new motherboards?
So you wouldn't want to go in and drop in compatible, because you have to do a BIOS upgrade. So physically it fits in the motherboard. Once again, if you're going up to the higher speed, we had to tweak the motherboard. It's essentially the same X11 family, but you wouldn't want to go retrofit a board. You want to buy a new system. There's little minor tweaks. Okay. Oh, other point was that Intel has finally launched their 3D XPoint solution, codename Optane. So it's been a long time in the works. Quite frankly, they were even developing it when I was still at Intel over 5 years ago. So it's finally been launched in the market. You think of it more as a evolution than a revolution. So this is the step one in the journey. It's a big deal from a software perspective to take advantage of it. If you're doing a high-end in-memory database or some very specific type of applications, you will absolutely see that performance benefit of Optane. But don't think that every system's going to have Optane right out the gate. I put this slide in from one of my friends at Micron. His name was Andrew Braverman. And what he tries to do here, for those of us, like I said, I'm a chip head. I like to geek out. And I even forget sometimes the differences in latencies between the various tiers of memory. So what he tried to do here was put this into human terms so that you can really see what a performance difference is. And show where Optane fits in that continuum. So what this slide is going to build out and show is it maps 5 nanoseconds into 1 second. So that's what the conversion rate is. So when you're doing anything on the CPU or with DRAM, it's very fast latency. So you basically have 5 nanosecond latency out of cache, which is very small but very fast, and then DRAM is in that 30 nanosecond range. So, but this is, of course, very volatile memory. When power goes off, you lose all your data. But just to put this into human terms, you can look at the 1 second, the 6 second. Then if you go on the other end of the spectrum with a traditional hybrid SAN array, you can look at 2.5 months. So I always talk about that's the difference. People forget about how slow a SAN array is compared to what the CPU is saying. So if he's fetching data from that SAN array, it's like, okay, I'm going to go on vacation, I'm going to hang out, I'll come back, I might mow the lawn, plenty of time. And so putting these in human terms really starts makes people realize, how important fast memory is in the memory hierarchy. Obviously, if you go with all flash, it's going to be better. You go with a hard drive that's direct attached, that's going to be more in the 2-week range. If you go to an SSD that gets faster, we personally believe that anyone who's using all flash SSD should be using NVMe. To me, it's such a no-brainer. It'd be like driving around your car with some hay in the back to feed the horses. Why would you take flash and use the same interface that was designed for something that was physically spinning? And if you talk to any of the SSD vendors, they like to refer to hard drives as spinning rust. Anybody in the room actually using NVMe today? Okay, good. Once again, getting these latencies down, and I'll just build this out. So if you look at NVDIMM and then Optane, that's where it sits in the hierarchy. But this is one of like I said, my favorite slides. I'll give out, to people taking pictures. I give all the credit to Andrew from Micron. I actually think he's at Dell EMC now. So he gave me this slide back in the day, and I just think it's, it really frames it because once again, we're a lot of engineers in this room, and we kind of know this at a high level, but when you put it in human terms, it really, brings the concept home of what a big deal it is to move, move your storage up in this hierarchy. So I just want to give a very high-level overview of some of our products. Like I said, we launched over 100 of them with Intel on Tuesday. But we're trying to really look at the different types of verticals that we would present our products in. So first of all, on the data storage side, we have our standard Ultra servers. We also have our Big Twin. We sell a ton of these Big Twins. We were the innovators that came out with the 4-node 2U type systems early on. What makes our Big Twin different is that we were able to shrink our power supply and still provide the same amount of output. That allows us to make the nodes bigger, which allows us to do a 24 DIMM in a 2U, as well as put more add-in cards in that same dense form factor. So while you might have a car with 4 doors and 4 wheels, I have a car with 4 doors and 4 wheels, it doesn't mean they're the same car. And so for us, it's all about the optimization and what you can get inside that. One other thing I wanted to point out on this slide is our what we call our JBOFs, or just a bunch of flash. We've done this with the U.2 form factor. We've also done with the Samsung NF1, and we're also going to do that with the new EDSFF form factor. This goes back to, why is flash in the same form factor as a hard drive? Well, this because the systems were designed for that form factor. When you go to flash, you should really design for flash. And by putting into these longer, as Intel coined it originally, ruler type form factors, you get much better airflow. You don't have the back plane that's damming the airflow, and so you can do a lot more efficiency from both a cooling perspective and put more processing into the box. So, make sure that you're watching for the EDSFF and the NF1 flash form factors that are going to be become much more prevalent in the marketplace over the next few years. Anybody seen an EDSFF or an NF1? I'll take that as no. So it's, like I said, it's not rocket science, but once again, why would you put flash into a form factor that was really designed for a spinning media? And you can get a lot of systems optimization. So as you'll see over the next few years that NVMe is going to move to these custom flash form factors. It looks like EDSFF is going to become the standard. Most of the vendors have signed up to EDSFF as that standard. And if you look at the difference between an NF1 and an EDSFF, Samsung really optimized for their flash die, which was more of a square, and the other ones have more of a rectangle, and so EDSFF was more aligned to the rectangle. Now they could obviously do EDSFF as well, but we all know the standards wars, and what will become the de facto standard. It really looks like it's going to be EDSFF. One of the other key verticals is obviously large internet data centers, and we believe that in giving you the most density, the most flexibility, as well as we feel that helping the environment is very important. So one of the things we've done is resource saving servers. So we've done 10 years on our chassis and our power supplies, such that if you buy a Supermicro blade system and you want to upgrade, you can just switch the blades out. You don't have to take the whole chassis out of the rack, and more importantly, you don't have to throw it away, because somebody has to deal with this at some point. So it's one of our ways that we try to help the environment, is making sure that we can design the sheet metal and the power supplies such that they last a very long time, and you can just switch out the blades. Now blades are actually a wonderful architecture. One of the reasons that blades don't do as well commercially is that my friends in Texas tend to charge a lot for it, right? There's nothing wrong with the blade, but if they're going to charge a lot for it, then it doesn't become as economically feasible. We just view it as another commodity form factor, and that's our business model. The other thing I wanted to point out is AI. We have a bunch of different GPU systems, and if you look at what NVIDIA has done, they came out with their DGX to show what's possible. We came out to show you how there's cost optimization and even better performance. So just if NVIDIA offers one, just like a Google would offer one phone, we're the ones building all the different form factors and options of that type of solution. So we have a very broad GPU platform. We're actually doing a 10U16 GPU right now, which has caught the eye of some pretty interesting customers. But wanted to make sure that you're aware, if any of you are doing AI or ML, that we have a very broad portfolio targeted at the GPU type systems.
Are the GPUs on the motherboard?
No, these are cards. Yeah. Well, I mean, we have both, right? We have, but it depends on the system that you're using. But we both have the cards and the ones that go down on the motherboard. Okay. And then the last one I wanted to talk about was our edge solutions. So we have a very large embedded business that's growing as well. One place we definitely agree with our friends in Texas is that the edge is going to be larger than the cloud. I'm sure a lot of you have used Uber, but you still have a car at home, right? So there's for latency and cost reasons, you need to do both, and there's a lot of latency applications where the edge is going to be needed to do the processing. So we see this as a huge opportunity for the entire industry, and we're very excited with the 5G rollout. Wanted to make sure you understood that we once again do custom form factors for a given application. And especially in the edge, you want some short depth type chassis. So very, very small, compact systems that also take GPU add-in cards so that you can do AI and ML at the edge. So this is the overview of the products that we had. What I really wanted to do for those people who have specific applications, I wanted you to come up and talk to Alan, talk to Chengmu. I saw Ravi join in the back as well. So we have key software engineers that are doing our solutions. Alan, maybe I'll ask you to turn your mic on and just give a quick overview of some of the different products and solutions that you've been working with.
Sure, thanks, Eric. So I work in our storage group. It's known as SSG. So any of the components you see with an SSG suffix, that's really my baby. So what I want to do is really take a different approach. So Supermicro have all the parts and everything that Eric's gone through. I want to focus really on what you can do with these. So this is what's more meaningful to our customer base. So typically what we'll have in our lab is we'll have a rack for maybe Ceph, another one for Luster, another one for whatever, and so on. And what we'll do is we'll do benchmarks, put it through its paces, and then we'll run through that as well. So what I mentioned earlier, we want to make sure that we hit the sweet spot, that we don't over-engineer these, because you can put in the fastest components and we might get a customer that says, okay, we want to take one of your 60 bays and we're going to fill it full of NVMEs and it's going to go really fast. And we go, no. So you don't want to be paying 100 times the cost for maybe 1.5 times the performance. So this is my task really to try and see where it is. And again, we'd explain that if you're using 60 NVMEs, say with 4 PCIe lanes, you don't even have enough PCIe lanes. So you're going to have to do all this kind of conflicting. So again, we're trying to engineer a good solution that hits the right spot. And then we want to generate a lot of empirical data as well. So that if somebody says, well, what happens if I do this? Well, if you did that, this is what you would expect, and here's the data to prove that. So it's really generating mountains and mountains of empirical data with many variations as well. One of the particular ones that Eric spoke about, I think, maybe a slide earlier, was our NF1, which has got 32 NVMe devices. So the reason I mention that is because currently we're doing a Ceph situation with that. So I've got some of our micro cloud products, which are like the blades. They've got multiple servers. And what we'll do is we'll use 2 or 3 of those as clients. So we'll have up to maybe 24 clients hitting those across a high-speed interface. But the NF1s are connected using 100 gig interfaces. And I'm going to use 2-way replication on these. I'd love to use 3-way, but they're fairly expensive, so we always want to put them across different nodes. So we'll use 2-way, and I'm going to hit them with clients in incremental fashion. So typically what we'll do is we might start with 4 clients, 8 clients, and so on. It's always trying to find out where we start to plateau. And as well as that, we'll start with maybe 8 NVMe devices, then maybe 12 and 16 and so on, again, trying to find the plateau. So we want to always say where the best way is. So to come out with best practices, all these type of things, that's really where our role is. So again, if any of you want to get any of this information, we don't necessarily put it up on the website, but I can give you my contacts, and if there's any particular things, or if you say to me, I know you haven't done that, but maybe you could try this little thing. So sometimes we can do that if maybe some new devices come in and we can do some particular tests. I can't promise anything, but sometimes it's something that we could easily facilitate within our test thing. So we like to start up structured with a nice dedicated test plan, but as we go through it, we find out more that test plan tends to get bigger and bigger and bigger. So it's quite easy for me to adapt and adjust those as well. So again, we always try to focus very much on how we can go to market and talk to the customer about a real application, not just here's the system, this is the spec of it. No, this is what you get in a real world application. So that's really what our team does. We focus on that. So
any questions? And if not, I'll let you out early as promised and come on up and talk to our engineers. So like I said, I have Ravi, I have Chengmu, I have Alan in the room. We'd love to have you talk one-on-one. Thank you for your time. Thank you for joining the show.
thanks.